Hi, I'm going to show you a shortcut for integration by parts. It's called rapid repeated integration by parts. And because it's a shortcut, you may be able to guess that this won't work every time. But I'll show you some where it does. We're going to complete problems 1 and 2. In problem 1, it's not going to be real interesting, but you'll be able to see the formatting that I use. In problem 2, you'll feel like it's much more helpful. So what I'm going to do is the same thing that I did yesterday in terms of identifying what u is going to equal and what dv is going to equal. The difference is that I'm going to put these into columns. So u is going to be x, dv is technically the rest of the problem, including that dx, but you're going to see that in rapid, we kind of tend to leave this off. So I'm just looking at x and dx. What I want to do in the u column is take the derivative of this function until it turns into 0. So it'll be 1, then it'll be 0. In the other column, I'm going to go until I get to this location. So I'm going to keep integrating. Remember, we have dv, so I want to know what v is. So I'm going to integrate both of those. And because integration by parts says take u and v and multiply them together, well, here's u, here's v. I'm going to multiply those together. I'm still going to be using that piece of the integration by parts. So these two will get multiplied together. But what will also happen is that these two will get multiplied together. So I'm going to have negative x cosine of x, and then for multiplying these two together, I'm going to have minus sine of x times 1, and because it's an integral, I'm going to have plus c. But this answer is slightly different than the answer that we had yesterday. The difference is right here. This should really be a plus. And here's why. In integration by parts, you multiply u and v. Well, we did that, u times v. But then you have to subtract off the integral of v du. So I want the opposite of negative sine of x. So this really should be a plus right here. So I'm going to go through problem 2 right now, doing the same thing where I identify the column for u. And I'm going to take that derivative until I get down until 0. And then the rest of it is going to represent dv. Once again, though, I'm kind of ignoring this dx idea. See if you can finish this up right now. Hit pause and then start it up to see if you have the right column for dv. Did you finish the column at the right spot? Rapid repeated would say that you want to multiply these two together, these two, and then technically the rest as well, but because they would all be zeros, that's why I'm saying that you could just stop there. It'd just be 0 times a bunch of things. So here's my answer, not something I have to integrate, my answer to integration by parts. Again, I'm going to multiply these two together. Negative x squared cosine of x. But remember, I need to take the opposite of this one. So what I'm actually going to kind of do is say, all right, this one's positive, this will be negative, then the third one would be positive, and if I had another, it would be negative and positive, and it would alternate back and forth because of the fact that the integration by parts formula alternates back and forth. So for this middle piece, it's going to be positive 2x sine of x, and for the last piece, it will also be positive 2 cosine of x. And because we're integrating, Ethan would remind you, don't forget the plus c. I'm going to look at a problem that may initially look like a rapid repeated integration by parts, but it actually won't work. I haven't told you the second rule. The first rule was I need something whose derivative would get down to 0. All right, and that's going to work here. But the problem is that the rest of it needs to be something that I could integrate. So in this case, I need to be able to integrate the natural log of x, which I can't do. So rapid is not going to work here. This is still going to be an integration by parts problem. It's not going to be a rapid, but I still want to show you what I would do with this. So I'm going to go back to more of my standard integration by parts. And because u or dv needs to be integrable and I can't integrate natural log of x, the natural log of x is going to be my u, and my du is 1 over x dx. Which means that dv is the other piece, 5x cubed, and v then will be 5x to the 4th over 4. And if I go with the standard integration by parts, I have u times v minus the integral of v du. I'm going to put that 5 over 4 up in front. du is 1 over x dx. And integration by parts is working if you have something that you could actually integrate. Notice this is going to turn into the integral of x cubed dx. So I'll give you a minute to pause and see if you can get the correct answer. Did you get this answer? Your goal today is going to be to get through a worksheet and be able to identify when to use rapid repeated integration by parts, as well as to actually be able to do it. But the worksheet will be similar to the other day in the sense that you're going to have some where you could just go ahead and integrate right away. There's really nothing you need to substitute in. We just kind of have a rule for it. Or you're going to have some where you need to use substitution, or some where you're using integration by parts. And then within integration by parts, remember some of them are going to be ones where you would just use the original regular integration by parts versus the one that we learned today, which will get you through the process faster if you have something that can get a derivative down to 0 and the rest of it you can actually integrate. Good luck.